Hello everybody, welcome back on a conversation on artificial intelligence, and today we're going to talk about something interesting. So basically, how intelligent are really intelligent machines? Are they really so intelligent? So let's start from an experiment, okay? Hey Google, how are you today?
I'm doing great. Thanks for asking. What can I help you with?
Oh, okay. What is the weather like tomorrow?
Tomorrow in San Jose, it'll be partly cloudy with a high of 71 and a low of 52.
Hey Google, that's very good.
Happy to help.
Hey Google, what can I do to have fun tomorrow?
One fun joke coming up. What's orange and sounds like a parrot?
So this is artificial intelligence. You can tell right away how you get out of some kind of priest. So it is what it is. This guy, I don't talk to her anymore because it gives to my nerves, but very far away from my dream Machina type movie, or Space Odyssey, or all the good movies that we have seen. But let's see why we think artificial intelligence has gathered lots of attention. There have been the like of Elon Musk or Gates that have said that it's very risky for the humanity to go down that path. But we're not there. So that has received lots of attention, and why? I mean, we're not really yet there. So in this video, what I want to do is I want to explain why we're not there, how we intelligence of these machines, and what are the problems, and how scientists are solving them. So to begin with, let's see why artificial intelligence became so interesting again, and why it attracted so much attention. It's because there were two breakthroughs. Basically, back in 2015, two different teams, Google and Microsoft, demonstrated independently that they were able to develop algorithms that would recognize images with the precision that is superior to what a human being would do. So it means that on these very large tasks of recognize thousands of images, the machine is more precise than a human being. Same thing in 2016, Microsoft came up with the breakthrough in which they demonstrate that their algorithms can basically they can translate voice to text with a much higher precision than human beings. Okay, because of that, people start to think the era of replacing the human thinking is on the verge to happen. But that's not the case. That's not the case. We will see it. So at that period, it's when the so-called deep learning architecture have started to really overcome a number of performances that a human being can do. And deep learning is one way, one methodology, it's a math methodology that is used in machine learning. And it's not the only type of algorithm possible, but it's a type of algorithm that has been very successful in the last few years. So people start to think that deep learning maybe was very close to approach human intelligence, but the reality is we're not there yet. And why is that? Let's try to give some structure to what we are basically discussing here today. So at the very first level, scientists noticed immediately that there was a technical problem with this new class of algorithms that go by the name of deep learning. And they saw that, for example, when they classify images, they were very precise, but uh, even inserting a little bit of noise in the image could lead to completely different results. So, for example, you have a picture of a panda, and you inject some noise in this picture, and all it happens is that the algorithm now it's unable to classify the panda as a panda, but rather thinks that it's a gibbon. And that was something on which scientists have been working in the last 3 years. So to be fully honest, there have been at least 500 citations of the original paper that pointed out this problem. So I believe that the problem has been mitigated, but you see the technical layer is not where the problem lies. The problem lies on the way this algorithm works versus the way that our brain works. And the fact that there are at least two fundamental abilities that are missing. The first one is the ability of abstraction. So, for example, if you teach to a robot to being able to grab a cup, then you have to restart almost from scratch to teach how to grab a glass. And so that ability to go from having learned a task and then extending it to another task becomes very, very limited in the case of these algorithms. The second level where machines are different today than human beings is the reasoning. So here is another example that is widely cited in the criticism to the effectiveness of machine learning. And it's basically a case where an algorithm has to decide what a baby has in his hand. So the baby actually has a toothbrush in his mouth and is holding this toothbrush with the hands. Now, the algorithm comes up and says that the baby is holding a baseball bat. How can it that be? So now let's analyze from a human perspective what would happen. The first thing that you do is that you're thinking of a baby. So a baby is very small, cannot really, like getting a baseball bat in his hands. Second, if he's putting something in his mouth, most likely it's something that has to do with hygiene. So you are thinking as a human being, you are reasoning, you're thinking. So as a human being, you hardly would come up saying that the baby has a baseball bat into the mouth because it doesn't really make sense. There is a lot of contextual information and a lot of thinking and reasoning out of just the information that you're seeing that the human beings uses to reach the end result of giving an answer, even if maybe the picture is not so clear. But the machine cannot do that. At least cannot do that as of today. Now, those are kind of, the cognitive skills the machines do not have today. But let's go a little bit more into the technical details without, getting into extreme details and understand what are these limitations today. So the first thing is something that we have already mentioned many times, is that in order to go from one task to another, the machines needs a gazillion of training data. What it means. So let's make an example. This is a mobile phone and these are earplugs, okay? Now you want to teach a computer that, or an algorithm if you like, that this is a mobile phone and these are earplugs. What you need to do is basically have to come up with 10,000, 50,000 pictures of this guy or similar guys from different angles and label each of that picture with a name, okay? Then you will have to do the same thing for this other guy and label, meaning you have to associate a name to each of these pictures that you bring on the table. And then you go through this process is known as learning, but imagine it is like you're teaching to a baby, basically. So at the end of the process, the algorithm will be able to distinguish between this and this. And will tell you this is an iPhone, and maybe if you show it like that, it will tell you it's an iPhone. And if you show this like this or like that, it will tell you this is a earplug. But if you do something like that, okay, there is a good chance that if the algorithm is not trained properly, it is gonna get crazy. And what it means the algorithm is trained properly? It means that the intelligence for solving this type of situation needs to be forecasted by the human being. So ultimately, the key to solve the problem is coming from the human being that is somehow teaching these models. So that's one level where the human intelligence is embodied into a specific problem to be solved inside the algorithm. Another level where the human intelligence is used today is in the architecture of these algorithms. So basically, it is the human being that decides what algorithm should be used and what type of architecture. In the case of these famous deep learning algorithms, they are algorithms that go by the name of neural networks. And basically what the human being does is it decides how many layers are gonna there of pseudo neurons, how many total neurons are going to be there, how these neurons are going to be connected with one another, and so on. So all of this, the so-called topology of the network, is basically encoded by the human intelligence. So these systems are not that intelligent, and that's one of their greater limitations. Ultimately, they resolve a task, and a lot of the intelligence that is embodied into these algorithms, it comes from the data scientist, who is a human being, that is encoding that human intelligence at two layers. One, in the nature and structure of the algorithm and various other things, including lots of other math around this. And two, in the way that the human being is training this algorithm, because it's teaching in a way that it's trying to minimize the algorithm to go nuts when it faces a situation that was not forecasted before. So that's the reality of today. So there is no reason to be really, really scared. But there are reasons, though, to be excited because things could evolve from where we are today. So scientists are looking at the possibility of creating combination of algorithms where some algorithms will be used for the ability to abstract, some algorithms will be used to decide which algorithms to use for a given problem, and some other algorithms will be used to generate new algorithms and new code from scratch. Basically, the combination of these three things, it will make machine resembling a little bit more closely the human beings. They will not still be able to solve any type of problem, but they will start to acquire the ability to solve problems from which they have not been trained or programmed. And one example of this is an article that I cite in the description of this video. If you watch it on YouTube, if you watch it on other place, please go on YouTube and look at it. So there is an article from Google Brain and other researchers where they basically demonstrate the ability to do the same function that we described before, the classification of images, with an intelligent, let's say a more intelligent algorithm, an algorithm that doesn't need the human being to choose all the details of the algorithms or the topology of the algorithms. This is an algorithm that searches for the right structure of the algorithm on its own. And so basically we're moving from one level where the complete intelligence rests on the human being that has kind of designed the algorithm, to a level where the algorithm itself is kind of adapting himself to solve the problem. It's not, I mean, there's still limitations, but this is a considerable improvement. Now, the one thing that is also very, very interesting in the Google Brain paper is that the computational complexity, the amount of time required to train these algorithms, and the amount of computational power, so the type of machine that are needed, are within reach, and they can be forecast, and we can have applications that can be made with normal computers. You're not doing something utilizing an incredible, sophisticated, huge computer. So that's a considerable progress, and it's one step towards strong artificial intelligence, one step towards the type of problem that we discussed in the previous video with the church CTO. And if you like, go back and go and watch that video because it was very insightful about problems that cannot be solved by single algorithms. Now, with that said, we have basically in this video we found out that we're still considerably more intelligent than machines. Maybe one day things will change, but we're still considerably more intelligent than machines. We found out why machines are limited in their intelligence today, and we found out what will be the next steps the scientists are taking to make machines more intelligent. Now, that's, to me, extremely exciting, and I think there are plenty of opportunities for human life to be improved, and also for science and technology to be drastically accelerated, because these systems can actually augment the human brain and help scientists, engineers, and also managers to develop even further and more advanced technologies. With that said, thank you so much. It was a pleasure. If you have questions about this particular video or other ones, please leave them in the comments, and I'm happy to make other videos that will address that. Thank you so much, and have a great day.